Continuing on in chapter 31, your book talks, we've talked about what inflation is. Deflation is just the opposite. It's where prices are going down in general rather than up. Your book then goes on and talks about the cost of inflation and deflation. And these can be maybe not what you're expecting. Be sure to read the book on this and watch the MRU videos. They do a good job of covering this. I want to talk in particular about one of these, and that is the redistribution of wealth. When you redistribute wealth, I mean, some people are gaining, and their gain is at the expense of somebody else. And inflation, when it is not anticipated, when it's unanticipated, it does redistribute wealth. Some people benefit from it, some people are hurt. And we can predict, we can figure out who's going to gain and who's going to lose. And you may be surprised by the winners and the losers. Let me share here for a moment. Okay, notice the graph here. You've got time on this axis, you've got the interest rate and the inflation rate on the vertical axis. And over time, notice what is happening. Starting in the mid-50s, you see interest rates in the red. They're generally going up. And they go up until the early 80s, and then they start coming back down. Why is that? Well, then you also see in the blue the inflation rate. And you see that it went up, came down, generally went up, spiked several times, gets really high in the early 80s, and then it comes down, and you see a lot of variation there. And you also notice a connection that when inflation is going up, interest rates are tending to go up, and when inflation is coming down, interest rates are coming down. Okay? Now, when two things are correlated, when they move together, that doesn't necessarily mean one is causing the other. But in this case, we have very good reason to believe that there is some causation there, and that the causation runs from inflation to interest rates. And we can think about why that is. Let's say that I want to, or you want to borrow $100 from me, and I'm going to charge you an interest rate of 20%. Okay. And let's say it's a one-year loan, very simple transaction. So at the beginning of the year, I'm going to give you $100, and at the end of the year, you're going to repay. You're going to repay that loan, the principal plus the interest of $20. And we would assume that I, the lender, I'm going to benefit because I'm ending up with more money than I started with. But when you have inflation, what seems obviously clear may not be actually true at all, because we've already talked about how what is important is not the number of dollars you have. What is important is the purchasing power of the dollars that you have. And I think we talked about this a little in class. Just to put this into purchasing power terms, let's say that I spend all of my money on hamburgers. That's all I buy. So it's very easy to calculate my purchasing power. And let's say the price of a hamburger when we make this loan is $1. So when I give you $100, I'm really giving up 100 hamburgers. And where did that come from? And when you repay the loan at the end of the year, if, let's say, we're all assuming that there will be no inflation during the year, and so we're expecting that hamburgers will still be $1 a piece. So when you give me $120, I'm going to be able to take it and go to McDonald's and buy 120 hamburgers. So if there's no inflation, then I, the lender, clearly benefit. I start out with the equivalent of 100 hamburgers, I end up with the equivalent of 120 hamburgers. But what if there's inflation that neither one of us anticipated? I lend you the money, 20% interest. What if during the year prices double? That would mean 100% inflation rate, which is not likely to happen, but we're going to use that just to make it easy to do the arithmetic. If prices double, then that means at the end of the year, when you give me $120, I'm happy. I think I'm a lot better off. Got $20 more. I go to McDonald's. Oops. I find hamburgers are $2 a piece. I have more dollars, but each dollar has only the half of the purchasing power of the dollars that I gave you to begin with. So with that $120, at $2 a hamburger, I can now purchase only 60 hamburgers. So my real wealth, in terms of what I can buy, started out as 100. It ends up with 60. I have more dollars than I started with, but the purchasing power has gone down. And here, this is a 40% drop in purchasing power. If this is all that I have, my real wealth has gone down by 40%. And, hamburgers, you might think, well, that's not very important. But this is exactly what happens when people make loans at a fixed interest rate, whether it's $100 or $100 million. If there's unanticipated inflation, look at the effects. It's very easy to summarize these effects. Lenders lose. When there's unanticipated inflation, lenders lose and borrowers benefit. Just remember the alliteration there. And think about why this makes sense. Because of the inflation that is occurring, the dollars that the lender repays have a lot less purchasing power than the dollars they got to begin with. So I gave you $100. Think about the purchasing power of each of those dollars initially. Each dollar, when the price of a hamburger was $1, each dollar would purchase one hamburger. But when the price of hamburgers goes to $2 a piece, the purchasing power of $1 has dropped to only half a hamburger. So because of this unanticipated inflation, the borrower gets to repay the loan with dollars that have a lot less purchasing power than the dollars he received to begin with. And that's why at the end of the year, although the lender has more dollars, he has less purchasing power than before. The lender is actually worse off in terms of purchasing power. And the borrower is actually better off because he borrowed the money, because he, in effect, got 100 hamburgers and he only had to repay 60. This is what happens when you have unanticipated inflation. And it's very important to remember. Inflation has been very low, around 2% or less, most of the time for the last 20 years. In the future, inflation may go up. Can't say that for sure, but it's definitely a very real possibility. And if someone lends money at a fixed interest rate and then inflation rate goes up, the lender is going to lose out. Now, think about at the end of the year, I'm the borrower, I'm the lender. What if I come to you and I say, that really wasn't right. You didn't pay me enough because I ended up worse off. I say, you need to give me more money. What are you going to say? You're going to say, well, no, you said you wanted 20% interest and that's what I gave you. Don't complain. And I won't have any legal right to complain, but I will be correct that the my purchasing power was diminished because I made you that loan. Now, what if you say, you're the borrower, what if you say, well, I want to borrow again. Okay? How about you lend me $100 for another year? Okay? Am I going to do that? Let's say we both expect, okay, the book uses pi to represent the inflation rate. Okay, so it's not 3.14, just a symbol to represent inflation. And we use a superscript E to represent the expected inflation rate. Well, let's say that we both believe that for the second year, the inflation rate is going to be 100% again. Prices are going to double. That's what we think. Am I going to lend to you again for 20% interest? No. I'm going to want compensation for that inflation that we're both expecting to occur. And this is where we get into what is called the Fisher effect. And the Fisher effect is summarized in an equation which says that the nominal interest rate will equal, or sometimes called the money interest rate, will equal the real interest rate plus the expected rate of inflation. Okay? Think about, what does real mean? We came across that back in the chapter on GDP. Real always means inflation adjusted, or in terms of purchasing power. Okay? Nominal is always in terms of current dollars or in terms of money. Okay? In our initial example, when I, the lender, was expecting that there was not going to be any inflation, I thought my purchasing power was going to go up by 20%. Okay? So I was expecting a 20% increase in my purchasing power. Well, if I still want a 20% increase in my purchasing power, then what nominal or money interest rate am I going to demand? Well, I'm going to want 20% plus I'm going to want the rate of inflation we're expecting, which is 100%. So if we're both expecting this high rate of inflation, what happens to the nominal interest rate? It goes way up. Exactly what we saw back in our chart here, that as inflation went up, interest rates went up. Basically, lenders were catching on. Lenders, as they saw inflation going up, they said, oh, the borrowers, he's going to repay the loan with dollars that don't have as much purchasing power. So I want compensation for that. I want more, a higher rate of interest. I want more dollars. And that is exactly what the Fisher effect, the Fisher equation, is telling us should happen. When people start to expect more inflation, then lenders are going to demand a higher nominal interest rate because they want to be compensated for the fact that the borrower is going to repay the loan with dollars that aren't worth as much. The Fisher equation is really, really important. In a lot of ways, the most important thing to see is that when people start to expect a higher inflation rate, then nominal interest rates are going to go up. We can also turn that around. We could take the equation as listed here, and we could solve it for the real interest rate simply by subtracting the expected inflation rate from both sides of the equation. And let's do that right here. If we do that, then we would get the real interest rate will be equal to, think about what you're going to get. We want to isolate the real, so we subtract the expected inflation rate from both sides. And so we get the real rate will equal the nominal interest rate minus um, the real interest rate here is going to equal the nominal interest rate minus the expected inflation rate. So the nominal interest rate is telling the lender how many dollars he's going to get back in terms of his return in dollars, but then the inflation rate is giving an indication of how much of that is just compensating for inflation. So think about what if someone was going to charge you, they're going to lend you money and they're going to lend it to you at an interest rate of 50%. Is that a really high return? Are they going to really get a great deal if they're lending to you at that interest rate? Well, that seems like a really high interest rate, but you have to ask, what is the real interest rate going to be? If the expected inflation rate, if it were 60%, what would that tell you about the real interest rate that the lender was going to get? Okay? 50 minus 60 would be minus 10%. So think about what these three numbers mean. The 50 means when the lender loans out money, he's going to get back 50% more dollars than he loaned out. But the 60% expected inflation rate means that prices are going to go up by 60%. So he will need 60% more dollars just to have the same purchasing power that he started with. So he's going to have, at the end of the year, the lender will have 50% more dollars, but he will need 60% more dollars just to break even in terms of purchasing power. So his purchasing power will actually have gone down by 10%. He has more dollars, but less purchasing power. And if he continued to lend under these conditions, every year, the end of the year, he'd have a whole lot more dollars and he'd have 10% less purchasing power. Eventually, he would just be flooded with dollars that would have essentially no value. It's very important to distinguish between nominal interest rates and real interest rates. And when you see interest rates reported in the news, always remember those are nominal interest rates. Now, one more thing, if we look at interest rates at present, here I have from the Wall Street Journal, you can get to this page without a subscription. This column shows you the return you can get today if you invest in government treasury securities, treasury bonds, with these different maturities. 1 month means you get your money back after a month. 30 years means you invest it and you won't get your money back for 30 years. The yield tells you the annual rate of return that you will be getting over the life of that investment. Notice here, what if today you decided to purchase a 30-year government bond? Okay. Well, if you bought it today, then you would be locked into be guaranteed a return, roughly a nominal interest rate of 1.324%. this year, next year, every year. That's the nominal interest rate you would be guaranteed. What real interest rate would you be getting if you invested in the security, which really means you loan money to the government, okay? Well, use the Fisher equation. The real return will equal the nominal return minus the expected inflation return, or expected inflation rate. If you bought this 30-year bond, then you would be locked into a nominal return 1.324%. What's the inflation rate going to be? Well, we don't know. We don't know. But in the past, the inflation rate has been about 2%. So let's say that over the next 30 years, the average inflation rate is 2%. That means that if you invested in this security, the real return after adjusting for inflation would be 1.3 minus 2%, which I should have calculated that before, something like 0.676%. And that is negative, which means year after year, even though the dollar value of your investment is going up, the purchasing power of your investment would be going down. Obviously, that's not a good investment. Why are rates so low? Well, that's a part of the current crisis situation we have in the economy and the financial markets. And things go back to normal, we would expect that this rate is going to go up, would be higher, and would be sufficient to more than cover the expected inflation.